Okay, so now we will get into something more concrete. I'd like to get away from some of the theory behind model-based definition, and we'll get into real workflows that have seen some success in terms of model-based definition and in terms of QIF. So these are workflows that CAPVIDIA has been working with its customers, and I think that they could be good experiences for everyone to learn about.
はい、ここからはですね、企画の紹介じゃなくてですね、実務の方のワークフローに入ってきます。で、実際にCAPVIDIAのツールを使ってもらうユーザーでの、ワークフローをご紹介していきます。
So, how are we using QIF in the real world? So it all starts out, of course, with a native proprietary model. So this might be Creo, this might be NX, this might be CATIA, maybe it's SolidWorks or Inventor. It's some CAD data where you are specifying 3D annotations in your CAD model. From there, we will generate a QIF model that is a derivative model, and it will exactly match the native model with all the 3D annotations. So that means that in the QIF model, we have the model, we have 3D annotations, we have all of the presentation states and saved views, all the attribute data. From there, we can build up this bill of characteristics that I have mentioned a couple times, which is a very important part of the quality planning workflow. With the bill of characteristics, we can assign IDs to all of the PMI, which we call balloons. And of course, this data, the QIF data, can of course be validated to make sure that it matches the native model. And this way you can feel safe with your MBD workflows using QIF models.
はい、なぜ QIF 使うかというところの説明で、左側のものがですね、ネイティブの CAD で、各社使っている CAD になります。でこれに PMI とかも、交差付与してもらったモデルがですね、QIF 変換すると完全な一致した形でデータを持ってくることができますよ。まず、サーフェスジオメトリー CAD のサーフェス情報ですねに PMI のアノテーション情報で、属性ですね。あと、アノテーションビューとかいろいろ言われるその見た方向と一致するようなビューの情報に関してもちゃんとネイティブ CAD から全てちゃんと持ってこれると。さらにですね、そこからですね、特性表として品質保証で使う、プランの結果もこのマシンビューでちゃんと持ってくることができます。で、ちなみにコンペティビディという、ドイツ検証のツールで、元と完全に一致していることが、検証取れます。
Okay, so now we'll get into a few different workflows. What I would like to do is give a very high-level explanation of the general idea of what our customers are doing with QIF. There will not be a lot of detail because it would take a very long time, but if you would like to learn more, please do come by and visit us, and we'd be happy to talk more about this after the presentation.
はい、これからですね、実際の、ワークフローを紹介していきますけど、かなり時間も短いので、概要を説明していきます。もしご質問ともあればですね、講演終わった後にですね、Y20 という弊社のブースにお立ち寄りください。
So our first workflow is a very basic workflow, but it's the foundation for all of the other activity that can happen throughout QIF. And this is about ballooning the model, as we call it, and doing inspection reporting. So this is about building the bill of characteristics, first of all, and then generating various forms of inspection reports. So what we'll see in this video that Nakamura-san will explain will be how we start with our QIF model, we add the balloons to the model, and we build our bill of characteristics, and then from there we are able to generate reports in various formats that do not require special CAD software and are good for consumption on the shop floor. So for example, Excel reports for inspection, and also a 3D HTML report that allows for viewing in a browser in a 3D manner. So I'll start the video and
はい、最初のワークフローというところでこのビデオがですね、最も基本的なところをご紹介します。ネイティブ CAD からですね QIF 変換してもらうと。でMDBA というツールに読み込むとですね、そこでもう、バルーニングでその、測定項目ナンバーですね、日本だとナンバリングとか交番とかいうものですね、 がその測定、交差ごとについてきます。でそれの合わせてですね、一覧でですね特性表という BOC というものがですね自動生成されます。これに、PMI 情報なんで、CAD にはない品質保証の情報とかを追加編集していくところの工程になります。でさらにですね出来上がったものはですね、このソフトを持ってない方でもですね使えるように Excel の検査表を書き出しましょうと。でこの Excel の検査表にですね、タグ番号が打ってあるんですけど、そちらをですねがリンクされてですね、ビュー、スクリーンショットの連携取れるような形になっています。なのでこの Excel 一つだけでもですね、3D モデルのスクリーンショットがついた形の検査表になります。でさらにですね新しいバージョンではですね、QIF からこういう 3D の HTML に書き出しもついております。これによりですね、特別なツールは不要です。今ホームページ見ているブラウザーでどこでも見ることができます。で特性表が下リンクしてて、選んだものがちゃんと CAD のサーフェイスがハイライトされるので測定箇所とかが、一目で分かるような形になっております。
And from here, we can build on that basic workflow, on that simple workflow. You can build on your implementation in later stages and get into more advanced types of quality workflows. So let me explain a little bit about that. So in some of these advanced quality workflows, sometimes in some industries this is referred to as APQP, Advanced Product Quality Planning. There is an additional layer of quality planning that can take place above just the ballooning. So again, we will start off with our native model, our native Creo, our native Siemens, our native CATIA model, and we'll generate that QIF MBD derivative model. From there, we can create the balloons on the model and build the bill of characteristics, just like we saw in the previous video. Now from here, you can begin to do more advanced quality planning that helps you to build a robust quality workflow, but you can do it in a digital way to ensure that there is consistency and uniformity in the process. So what does this mean? You can link your design FMEA data, your product requirements, to the model so that you can automatically calculate criticalities based on your company's best practices. You could link your process FMEA data, so some of your process risks, manufacturing process risks, to the model data so that you can automatically calculate the statistical process controls that you need to implement in order to maintain a high quality workflow. With a list of QIF resources and possibly QIF rules, you can then begin to build the specific measurement plan that you will implement, including inspection frequencies, the devices that you will use to measure each of the items on your bill of characteristics, and so forth. Next, we will get into manufacturing the first articles. Once that is successful, we get to the stage of FAI approval or PPAP approval, and then we can get into large-scale production of the component. We can generate QIF results, of course, to do data mining and do analytics of the as-built data. And finally, a very important step is when it's time for the next revision of the model, you don't want to go through all of this work again. And with an MBD workflow, it's good because it's not necessary to go through all the work again. We have an understanding with MBD of what has changed in the model. And therefore, when you do the quality planning again, you only need to update the aspects of the quality plan that have changed in that revision. And everything else, you could leave it as it is.
これはですね、自動車部品の業界等に使われてですね、APQP とかいうですね、食品の、品質保証の計画の作るっていう話をしております。ネイティブ CAD から、QIF の MDB の、PMI を持ったモデルに変換しますよと、先ほどのスライドのようにですね、測定交番とかつけるところまではベーシックなところですよと、さらに高度な利用としてですね、この黄色3つのところですね、設計段階の、FMEA で、重要度、その形態どこの箇所が重要なのかというのを定義していくと。で次の工程ではですね、プロセスコントロールで、量産に入る前にですね、どこを SPC で管理するっていうところの、こちらの FMEA で作っていきます。で、QIF にですね、どの測定器使うとかですね、どうやった測定点取るとかっていうのが、情報があればそのテンプレートを使って、品質保証のプランを作ってきます。でそれができたらですね、実際に、食品 GD&T とかも言いますけど、GD&R か、FAI ですね、食品の検査工程に入ってきます。でこれが、合格になったら実際の量産に入るというところでドキュメントの生成、この辺も全部 CAPVIDIA のツールで自動生成するようなことができるようになっております。で実際はその、量産始まるとデータが蓄積されますので、そのビッグデータを使ってものづくりの補正とかですね、次の製品のレビジョンにフィードバックしますという話をしてました。
Okay, so that was a more advanced ballooning workflow. We will get into, let me quickly explain a little bit about how QIF and how MBD can be used for coordinate metrology. This is usually the first thing that, the first use case that people will think of when you think about good uses for model-based definition and for QIF. So I think it's pretty clear how it works. I think many people have, thought of this idea, but it is at this point a pretty widely supported workflow. So we'll start with our native model again. We'll generate our QIF derivative, and then from there we can load that QIF data in many different metrology software platforms. At this point, there are many CMM platforms that have implemented QIF since it's an ISO standard and since it has been around for quite a long time. For example, here in the center, we see the Zone 3 software, which has loaded that QIF model, and looking at the CAD model and at the PMI, at the 3D annotations, it was able to generate a measurement program automatically to make measurement planning process much easier.
はい、QIF 用いたですね、その、測定の効率化というところのメリットで一番最初に得られるのがその CMM とか 3D スキャナーのいわゆる測定に関連するところになります。ネイティブ CAD から先ほど言ったみたいに中間ファイル数 QIF、PMI 付きのモデルを変換してしまえば、それを使って、測定器 CMM のですね、パスの生成が非常に効率化できると。で、以前はですね、まだこれが全然出揃ってなかったですが、昨年あたりですね、弊社のもちろんゾーン3もあるんですが、フランスのですね、シミュラメトログとかですね、ヘキサゴンの PCDMIS、ツワイスのカリプソ、でちょっとこのロゴだけですけど、三豊さんとかも徐々に追加されてきています。で、点群処理系列車は弊社のコテムから筆頭に、ポリワークスさんといった形で、ソフトウェアツールが出揃ってきてますので、十分使える企画になってきております。
So that was CMM, coordinate metrology. I'll now get into another very interesting use case, which is visual inspection. So visual inspection, I would not recommend that this is the first MBD workflow that you try to implement, but we do have customers that are doing this, and it's a very useful MBD workflow. So let me describe in general what the workflow is, and then we have a short video, and Nakamura-san will explain some of the details of the workflow. So how we start is, again, we start with our MBD model, which will be in the QIF format with all 3D annotations. In that MBD model, you will see that there are 3D annotations that specify some of the visual checks that are necessary. In this case, in this example, we will be looking at this turbine blade to look for scratches on the surface. From there, that QIF model will be loaded into this software technology from this company called Kitov, which will load the QIF model, automatically calculate the inspection that needs to take place, meaning the camera angles, the levels of illumination, the robot path, everything. And then it can execute the program, and it can analyze the images, and finally output the results in the QIF format so that they can be viewed in the context of the 3D model. And so with that, I'll play the video, and here we go.
はい、次はですね、ちょっとオプション的な扱いなんですけど、今までの寸法測定みたいな話以外ですね、外観検査にも使えるよっていうところの QIF の紹介になります。これ、NX で、PMI にですね、中期で使ってですね、外観検査項目、今これだと3つだけなんですが、ついています。それがPMI 付きで QIF に書き出したよというサンプルを見ていただいています。モノアタービンブレードですね。で、これはキトフのソフトウェアで、これ QIF 読み込むとですね、外観検査用のこのロボットのハンドリング、回転位置とかですね、撮影場所、これ全部 QIF ベースに自動的に作ってくれますので、いちいちロボットの制御プログラムを作る必要はありません。で、このイスラエルのキトフというメーカーなんですけど、日本国内でも住13系が代理店やってて、三井さんも技術提携してますので、十分国内で使えるメーカーだと思います。で、その検査した結果ですね、MDVIDIA に持ってくると、外観検査の結果ですね、上がマスターの画像で、下が血管、脱痕とか傷とかってあったところは、これも PMI と連携して見れるような形になっています。モデル上にですね、血管箇所のリストが出てて、それをクリックするとその実際映像が見れるという形になっております。
So that's the visual inspection workflow, a very interesting one. Again, I would not recommend that it's the first workflow. I don't think it's the lowest hanging fruit or the best initial value, but it's a very interesting workflow and a very powerful workflow. Another workflow that is in some ways related to quality but also related to manufacturing is a welding workflow. So it's possible, of course, to specify your weld annotations in 3D in a semantic, machine-readable way on your model, and QIF is fully capable of carrying all the semantic information related to a weld. So, what are some examples of some of what we're doing with our customers in the weld area? Let me just explain a few. One is that we're able to automate the generation of weld quality control plans. What this means is that on each weld, there might be multiple different quality criteria that need to be checked for every weld. For example, the length of the weld, the depth of the weld, maybe looking for defects in the weld like bubbles or gaps. All of these quality criteria are things that are associated with a single weld annotation. We're able to analyze the weld annotations and build very complex quality plans from the weld annotation. We're able to generate weld quality plans and weld work instructions in the Excel format. This is a very important technology for our users that do a lot of welds, is being able to build these Excel documents that have work instructions for how to carry out the weld. And finally, a very interesting one is that there are weld robotics tools that support the QIF format. And so what we're seeing here in this video is the Delphi software, which has imported the QIF MBD model and is able to automatically generate the robot path necessary to implement these specific welds.
はい、今までがですね、寸法検査に関することばかりですけど、QIF 自体ですね、デジタルものづくりに関するデータが全部マシンリーダブルで埋め込めるよ。一つの、例としてですね、溶接関係になります。で、溶接でいうとですね、3つの重要なファクターがあるんですが、一つがまずですね、PMI のその溶接記号からですね、元にですね、その検査工程のですね、手順書なんか自動生成させると。で、これ CAD の PMI だけでは溶接記号しかないんですが、実際にはその品質でいろんな工程を調べなきゃいけないので、そういったものが、定義されたもののデータベースから組み込んできてレポートを自動化できますよと。で、それを Excel の、検査表とかの指示書を作ることができます。で、3つ目がですね、産業用ロボットを使った溶接の工程ですね。これで右側のデルフォイというソフトウェアですけど、これも QIF 読み込むだけでですね、ロボットと溶接の工程のプログラムが自動化できるというものになっています。で、これものは、トラクターとかその関連の部品だと思います。
So we've gone through all of these areas here. The final area that is kind of ties all of it together and brings it back to the full loop is gathering as-built data. In other words, gathering that quality data and associating it back to the model. So, what does this mean? We're able to gather information from metrology in a digital format and keep that in the associated to the QIF MBD definition. So what does this do? It establishes the digital thread between the design model that you will have on the engineering side and then the as-built data that comes as the result of the manufacturing. This is one of the most important aspects of QIF because lots of times we hear this concept of digital twin mentioned, but I think that there's a lot of ambiguity out there as to what exactly the digital twin is and how one implements it. But essentially what we're looking at is The digital twin means that you are connecting as designed data with as built data, and you are using some form of structured data to keep it all organized. And that's precisely what we see here with QIF, with the association of the CAD data with the 3D annotations, with the results data as built, and the structure is the ISO format to specify all of this data and keep it very well organized.
はい、今まで検査工程で作ったものをですね、asビルドって、建築系ではよく使われる言葉なんですが、解析データですね、実際の元の CAD データに対して、デジタルでですね、データ、測定結果と全部吸い上げて、リンクして表示することができると。で SPC の統計管理なんかもですね、こちらの特性表の中に、全部データを持ってこれる。CMM の特定結果だけではなくてですね、手動測定したものとか外観検査とか、そういったものは全部、ビッグデータで、一つに CAD と連携して、表示することができます。これが本当の最近の流行り言葉のデジタルツインでしょうということですね。
And so those are that's a handful of different types of QIF workflows that we wanted to show you. Again, the general idea is the workflows, you could think of them as starting from this area here, where we start with ballooning, just identifying everything that we need to measure. And then we can go through all of these advanced activities where we use the QIF data to carry out some form of automation in manufacturing or quality. And then at the final stage, what we have done is we've gathered data from all of these different areas, and we keep it so that it's linked to the original design data, which is another very important aspect. And again, using model-based definition as the core for all of these workflows.
はい、今の概要の説明のまとめです。MBD のその元のネイティブの CAD データをそのまま維持したまま、中間ファイルして QIF 使ってさまざまな工程で、役立てることができます。